very much. Thank you for the invitation. Best wishes to Frankfurt. My name is Thomas Strebin. I'm responsible as a product owner here from BMW Central side for the topic of identification and localization with a main software platform in the central of this product, which is called IPSI. And the target in the next 15 minutes should be to give you an overview about what was the challenge behind the platform. What is the platform all about, and what is the vision behind it and the future targets of our IPSI platform. To start with, I want to give you a quick overview about a BMW production network or a BMW production plant, where we have a complexity built up out of different technologies, where we speak about one technology as a press shop, for example, body shop, paint shop, assembly, but also components, manufacturer, engine production, seat production, and all in all, the overall logistics, which is delivering us with the parts for the assembled vehicle in the end. We speak about the complexity of different tasks. A lot of people are working inside. We have a lot of components here in Plant Munich, for example, and a separate engine plant within Plant Munich with over 400,000 engines a year. And the final product, also speaking from Munich, with 150,000 cars that we are producing here at that site. All in all, the future challenge for that is how efficiently and with a high quality to steer those processes to get a good assembled vehicle out of that. And one key factor which we recognized is the key is the position data. Where is what in my production process? And this is what my department is looking for there, where we are about to get a solution on getting the transparency on the one hand, to get the position data of each object on a valuable platform in the end. And this is what I want to introduce you with the IPSI platform. With IPSI, we did not develop localization technologies because there are, or there have been in the history, a lot of different localization solutions for different use cases. Our mindset is always that there is no one localization technology which could fit to each and every use case. So we have different approaches. We have GPS positioning, for example, for outside steering of trucks, which is good enough based on accuracy, and you don't need additional infrastructure for that. We have other use cases where it's all about identifying a large amount of objects, like logistic components, like engines here, where it's better to go for passive RFID in terms of costs. There are other technologies where later on the company of Ubisense will present one example here. We go into the area of ultra-wideband localization, when it's all about real-time tracking and tracing of objects in-house. And in the end of the chain, it could also be then GPS positioning by tracking and tracing of the final produced cars. What we recognized is that the number of localization use cases and the need of tracking and tracing of objects is increasing more and more. More and more is also the number of back-end systems which will be fed with position data. So steering of automated processes by position data is becoming more and more famous, and that's where we need a solution for. And on the other hand, we have a high variety already of localization technologies and different suppliers. And as I said, the mindset is not one single localization technology fits to each and every use case approach. And there's a need in the end, if you have a high variety of localization systems, that they need to interact with each other. And last but not least, all those topics should lead into one platform which could be configured easily by non-IT experts to get more and more in process optimization just by click and drop, beside a full IT programming background that you need. That's what we call shift left. So key users in the plan could individually and easily configure use cases. And the answer to this is our IPSI platform as a central platform sitting between all the localization data and the backend systems where the use case or the automatization happens. There you see we are talking about connectors on the bottom level, where it's all about getting the positioning data into IPSI to bring it on one standard format to have a harmonized localization data all over the plant. And on the other hand, upwards towards the backend systems, standardized services, which makes position data accessible for each and every backend system. It makes position data accessible for use cases which are not originally planned for one localization system. So yeah, you generate a lot more use cases out of an originally planned localization system. So we have a performant and scalable platform with standardized services upwards, one platform for all localization data in one plant to have in the end a digital picture of real-time position data of the plant, and this on one platform with the intuitive user concept as the key users in the plants where the processes can configure their processes based on position data. To go a bit more in detail, what was shown roughly on the last page here, a bit more in detail. So we're talking about basically three aspects in here. We're talking about the localization object layer, where the objects are that need to be tracked, but also the systems that make it possible to track and trace all the objects. On the other hand, in the middle, that's where the IPSI platform sits. We have different interface types to make as much as possible localization systems to be linked towards IPSI, and then all the processing of data like geofencing, when one object hits a geofence or objects are near to each other and we want to inform backend systems about that is working in the function layer, and then based on services we provide this data in a pre-processed way, in a harmonized and standard way to all the backend systems. How does it look like then in the end? And I brought you some screencasts out of different instances that we have. We're starting with a central instance, bringing us this GPS data of our finished vehicles worldwide, which is a main use case of coordinating the processes between a ready assembled vehicle towards the customer. One input source with a GPS system, and a totally different approach here. Once we jump into Plant Munich here, for example, where we have on one and the same platform real-time localization data for all our vehicles and the tools that are working with that vehicles, and we're automating those processes by configuring them on the plant layout and starting, stopping, and steering all the processes by localization data and giving a real-time view inside of each one of our production sites. Here you can see it for Plant Mexico, for example. And last but not least, in one logistics site, where we're doing the real-time tracking of containers and steering full and empties and steering the processes over by the position data. Where do we want to stand with IPSI in the future? And that's a very important part of my work here. We're always growing into two directions. The one is plant-wise. So we're about to bring the IPSI platform in each and every BMW production site. At the moment, we're working with 7 production sites having IPSI ready. By the end of the year, it will be 10. And later on, we're growing more and more in all of our production sites. On the other hand, having IPSI in one plant available makes people working with that, makes people having ideas, and we see a lot of new use cases coming. So starting with the tracking of tools, so the automated start and stop of a tooling process, over truck steering for logistics or worker assistance screens based on position data. So what car am I standing in front, for example, over route train tracking or steering processes between F1 and F2, which means between a vehicle is ready and a vehicle is about to be sent towards the customer. Each plant brings new ideas towards this use case list, and our our task is it then to industrialize it in one plant and bring it over as a standard towards all the other IPSI sites to generate value. With the overall targets in the end, we want to automate logistics and production processes triggered by position data in case of efficiency, but also in case of quality. Therefore, we also see and generate a strong competition between the localization technologies and suppliers. Where in the old world, we had a single source solution based on one localization technology working with one software. We now have an open platform sitting in between, and it's more about competition money-wise, but also function-wise between the localization suppliers, because the data is all harmonized in that IPSI platform, which then makes it easy to fast and flexible integrate new use cases without IT, just by drag and drop, or as you saw it in those screencasts, by simply adding more geofences, or as we call it, collision zones around the object, which makes the automation happen. And all in all, this is not for one single plant. We do it worldwide. Once a good idea grows to an industrialized use case, we bring it over to all IPSI plants and generate benefit for the whole BMW group. As the last slide, so to call, I would bring you one movie, which is the vision of IPSI, which was created in 2016, which is still perfectly fitting to what we are doing and gives you a good impression of where we started. The screencast gives you a short overview about where we're standing at the moment. Have enjoy the movie, and thanks for listening for the moment. I would stay in, and I'm happy to hear some questions if they are. So movie on if possible.
Day after day, we coordinate thousands of components, vehicles, and machines within our production network. One of the biggest challenges we face when doing so is being able to acquire and process position data in real time. Our solution at BMW? IPSI. IPSI acquires and collects information that lets us know exactly where the objects involved in our production processes are located. Modular functions store, process, and link the corresponding data centrally and provide it as a service for other applications. Based on the location data it receives, the system can determine when a vehicle and a tool get close to each other, enabling it to unlock the corresponding process automatically. Automatic guided vehicle systems also benefit from the central processing of location data, as their routes can be actively controlled by tracking their position in real time. Our vehicles can determine their own position, which enables us to use this information in order to create a virtual map of the vehicles at our BMW locations. The complete transparency we achieve gives enormous benefit to the processes that extend from the finished vehicle to its delivery. Our vision is to be able to precisely locate every single object involved in our production processes, regardless of the technology and positioning systems they use. This will enable us to provide the location information to a broad variety of independent services and business processes. And not just for each individual location, but worldwide. That's what the digital future looks like at BMW.